Oh, my knee. It hurts, my knee.
Hey,
Oh, hey.
well, if your knee hurts, then all you need is a knee replacement.
How did I do that?
For thousands of years of human existence, our ability to move has been essential for survival. From migrating across vast distance to simple tasks like walking, our mobility defines our independence of quality of life. But what happens when our mobility is compromised?
Today, we explore a solution to one of the most common ailments affecting mobility knee replacement surgery. In a world where movement is synonymous with freedom, the ability to address debilitating knee conditions is paramount to maintaining our way of life.
For individuals suffering from chronic knee pain or degenerative conditions like osteoarthritis, knee replacement surgery may become a beacon of hope. Understanding the procedure empowers patients to navigate their healthcare journey with confidence and clarity.
Stay tuned as we dive deeper into the engineering aspect of knee replacement and its impact on patients' lives.
As previously stated, the knee joint is a crucial part of the body. However, over time, as a result of high impact sports or other factors, one can eventually end up needing a knee replacement surgery. Now let's take a closer look into the knee joint itself and discover why one may need a knee surgery.
The knee joint is comprised of four main parts: the femur, patella, cartilage, and tibia. The femur is the thigh bone, the tibia is the shin bone, and the patella, also known as the kneecap, is a triangular bone that sits in the front of the femur and tibia. In addition, the cartilage sits in between the femur and tibia.
But what leads to the necessity of knee replacement surgery? Well, the breakdown of the cartilage between the knee joints is the primary driver for knee replacement surgery. Knee cartilage, a thin layer of tissue that is only 3 to 5 millimeters, which is about 3 to 5 credit cards, as seen here. And unfortunately, this layer of tissue doesn't heal or regenerate once it's gone.
Now let's look into what goes on during a knee surgery. As seen in this animation, the knee end of the femur, top part of the tibia, and the patella are resurfaced so that when the fabricated metal joints are screwed into the tibia and the femur, the fabricated ends will fit properly. In addition, they use cement to keep them together. From there, we see that a medical grade plastic spacer is put in between the femur and tibia, and a button is attached to the backside of the kneecap.
Now let's talk about the life after surgery. It's important to note that full recovery typically takes anywhere from 3 to 6 months. However, there can be a series of challenges post surgery. Patients may experience clicking, clunking, or popping sounds due to the new knee. Inflammation of the connective tissue inside the joints is also a possibility.
There is also risk of implant breakage, especially in cases of overweight individuals or those engaging in high impact sports using the knee implant. Moreover, soft tissue may sometimes move over the implant, causing severe pain for the patient. Additionally, stiffness of the knee is common, particularly in the first month following surgery.
Another concern is wear and loosening of the implant over time. If the plastic spacer between the femur and the tibia wears out, it can result in friction, wearing away the bone surface and causing the implant to loosen. To replace the cartilage, medical grade polyethylene spacers are utilized. However, it is important to note that these spacers can cause scarring, joint stiffness, and an increase in bone loss.
When you take a step, you're transmitting 2 to 3 times your body weight through your knees. Your knee joint operates with 6 degrees of freedom, meaning it can move in 6 different ways. These movements include rotations like flexion and extension, external and internal rotation, as well as translations such as anterior and posterior glide, medial and lateral shift, compression, and distraction.
Let's explore the normal active range of motion for our knees. Our knee can flex up to 135 degrees while fully bent and extend to 0 degrees as fully straight. It also has an internal rotation range of 10 degrees and an external rotation of 30 to 40 degrees.
Passively, your knee can flex up to 150 degrees, depending on your leg size, and extend up to 10 degrees, with hyperextension considered normal.
For instance, when you're walking, your knee typically moves within a range of 0 to 65 degrees. And when you're climbing stairs, sitting down, or even trying to tie your shoelaces, your knee undergoes specific ranges of motion tailored to each activity.
With the help of this computer-aided design, we can see further detail of how the knee replacement is implemented into the human body. On the top section, you can see the femoral component is connected to the femur, while the bottom portion, you can see how the tibial component wedges into the tibia. In between is the plastic spacer that allows smooth movement and rotation of the knee joint.
As we explored the realm of design for knee replacement, we uncovered the details that shape the future of mobility. From assembly to manufacturing, every aspect of design is meticulously crafted to meet the diverse needs of patients worldwide. The foundation of our approach lies in designing prosthetic knees built to last, ensuring designs for longevity.
The innovative design prioritizes harmony with the human body, crafting prosthetics that seamlessly integrate to provide natural movement and comfort for in body use. With a focus on simplicity for easy surgical installation, the designs facilitate swift and efficient surgical procedures, allowing for surgeons to navigate installations with ease and precision.
The commitment to accessibility ensures that prosthetic knees can be swiftly replaced or repaired, minimizing disruptions and maximizing patient convenience. Designed for functionality maintains the essential 6 degrees of freedom. The design preserves the natural functionality of the knee, empowering patients with seamless movement and flexibility.
The holistic approach on designing for ease of recovery extends beyond surgery, encompassing rehabilitation and recovery, ensuring a smoother journey towards restored mobility and quality of life. With every design choice, the dedication to design reshapes the landscape of knee replacement surgery, paving the way for a future where mobility knows no bounds.
So it is critical that the correct materials are selected for such a vital component. The implant material must be biocompatible, strong enough to take weight-bearing loads, flexible enough to allow for movements, move smoothly, and retain its strength through cyclic load.
It is most common for the femoral and tibial components to be made of titanium and cobalt chromium molybdenum based alloys for their high strength, biocompatibility, and high resistance to corrosion and tarnish. The plate is made out of medical grade polyethylene due to its high impact and corrosion resistance.
Unlike components that go into machinery, most biomedical components are more personalized to suit the customer's bone composition. Beginning the manufacturing process, the hip, the knee, and ankle undergo a CT scan to guarantee proper alignment to the neutral mechanical axis before the implant is designed for the customer.
Next, iFit technology takes the two-dimensional CT scan of the knee and converts it to a 3D model so that a wax mold can be used to form the metal components. Other manufacturing methods include powder bed fusions, which take the 3D model and harden the powder layer by layer with a laser. The excess dust is then removed through the use of a tumbler and compressed air.
Additive manufacturing is also a popular method by heating and extruding thermoplastic filament. Through advanced technology, knee replacement has become a reliable form of technology while the production remains sustainable. Finally, attaching the component requires either bone cement or screwing directly onto the bone.
The need for a knee replacement can arise from multiple factors, such as chronic knee pain, osteoarthritis, and traumatic injury. We see a lot of these injuries in competitive sports, especially contact sports like soccer and rugby. Former NBA player Bill Walton and NFL quarterback Joe Namath have both had knee replacements.
Knee replacements have innumerable benefits and uses to their recipients. These include pain relief, improved mobility and function, correction of deformity, and an overall improved quality of life.
In closing, knee replacement surgery represents a remarkable fusion of biomechanical engineering and medical innovation. From the careful selection of materials to precision manufacturing techniques, every aspect of the process underscores the advancements driving improved mobility and quality of life for patients.